Welcome, everyone. I'm thrilled to have you here today. In this session, we are going to master one of the most transformative techniques in AI engineering, few-shot prompting. Let's get started. Let's dive right into the fundamentals. Imagine trying to explain how to tie a shoelace using only words versus actually showing someone how to do it. That is the exact difference between standard zero-shot prompting and few-shot prompting. By giving Claude 2 or 3 concrete examples of your desired input and expected output, you shift from simply describing a pattern to actively demonstrating it. We call it few-shot because you give the AI a few chances to see the target output before asking it to do the actual work. It is the fastest, most effective way to improve Claude's ability to follow complex instructions and format strict data. Take a look at this architecture flow. On the top path, we have standard instructions flowing into the model. But on the bottom path, we inject 2 to 3 concrete examples. When Claude processes both the instructions and the demonstrated examples together, it combines semantic understanding with structural pattern matching. The result, on the far right, is a highly accurate output that strictly adheres to your required format. Why should we as engineers spend time writing examples? Because human language is inherently ambiguous. When you tell Claude to write a professional email, your definition of professional might differ entirely from Claude's default training. Few-shot examples serve to anchor the model's behavior. As our best practices dictate, examples are the absolute most reliable way to steer output format, tone, and structure. It minimizes the mind reader fallacy. Instead of hoping Claude guesses your exact JSON structure, your examples provide an ironclad template. This leads to massive reductions in hallucinations and formatting errors. This diagram visually demonstrates the operational value of examples. When we assign a data extraction task and use zero-shot, we often get inconsistent output, which leads to downstream application crashes. But when we route that same task through a few-shot prompt, we achieve strict schema compliance. The examples act as guardrails, steering Claude's neural pathways exactly where you want them to go, ensuring your downstream systems succeed every single time. Not all examples are created equal. To make few-shot prompting truly effective, you must build upon 3 core pillars: relevance, diversity, and structure. First, relevance. Your examples must mirror the actual production use case. Don't use generic fruit classification examples if you are building a financial analysis bot. Second, diversity. You must cover your edge cases. If your examples are too similar, Claude will over-it to that specific nuance. Show it a short input, a long input, and a complex edge case. Finally, structure. You must clearly delineate where the example starts and ends so Claude doesn't confuse your examples with the actual live task. Our breakdown here maps out the optimal example design. Notice the 3 pillars holding up our prompt effectiveness. Relevance ensures the domain matches the task. Diversity ensures robust edge case handling. Structure ensures the AI parses the prompt safely. When these 3 elements converge in your prompt engineering, you create a system that is virtually bulletproof against unexpected user inputs. Let's get technical with prompt structure. Claude has been specifically fine-tuned to pay close attention to XML tags. When you provide examples, you cannot just dump them into the text blindly. You must wrap them in example tags and group multiple examples together inside an examples block. This clear syntactic separation prevents Claude from confusing your historical example inputs with the actual live user query it needs to process today. By explicitly defining input and ideal output within each example block, you build a highly legible mental model for the AI. This is a non-negotiable best practice for enterprise-grade prompt engineering. Look at this structural node tree. At the top, we have our system instructions. The prompt then dives into the examples node. Inside, you see individual example blocks, each neatly divided into input and ideal output. Finally, completely separate from the examples, we provide the live user input for the current task. This structured hierarchy is exactly how Claude parses your prompt, keeping context pristine. Let's look at how this translates to code. Suppose we want Claude to extract product features from a messy description and output a strict JSON list. We build a prompt template containing an examples block. Example 1, input is a messy desk lamp description, output is a clean JSON array of features. Example 2, input is a wooden shelf, output is a JSON array. We close the examples block and dynamically inject the real user input. By doing this, we don't even need a massive, complex system prompt explaining the exact JSON keys. The examples do the heavy lifting for us. The pattern is implicitly learned. This is the essence of few-shot learning in code, less explaining, more demonstrating. Here is the sequence diagram for our code implementation. Your application injects the JSON examples and the live unstructured text into the XML prompt template. The complete package is sent to the Claude API. The LLM processes the template, recognizes the implicit JSON pattern from your two examples, and instantly returns a perfectly formatted JSON array back to your app. The examples completely bypass the need for complex parsing rules. Let's apply this to a real-world, high-stakes enterprise use case, automated support ticket routing. Imagine you receive thousands of customer emails daily. You need Claude to classify the urgency as high, medium, or low, and the department as billing, tech, or sales. If you just describe the rules in zero-shot, Claude might occasionally output critical instead of high, breaking your database. By providing 3 examples: an angry billing email, a mild tech question, and an urgent sales inquiry along with their exact expected JSON outputs, Claude locks into your specific business taxonomy. It learns exactly what high urgency sounds like in your context, achieving phenomenal classification accuracy. This system architecture illustrates our support ticket pipeline. The inbound email hits our classifier prompt. Notice the context nodes. That's where our 3 diverse examples are fed in. The LLM references these examples, aligns the inbound email against the demonstrated patterns, and routes the ticket flawlessly to the correct department. This visualizes how few-shot prompting acts as the core routing intelligence of an autonomous system. Now for an advanced deep dive. What if 3 examples aren't enough? What if you have a highly complex task that requires 20 or 30 examples to cover all your edge cases? Historically, this many-shot approach would consume too many tokens, inflating your latency and API costs. But with Claude's prompt caching feature, you can place a massive examples block at the top of your prompt and cache it. Subsequent API requests only process the new user input, pulling the examples directly from the cache. It's a game-changer for enterprise deployments, allowing you to fine-tune Claude's behavior using dozens of examples while cutting input token costs and response times drastically. This diagram reveals the prompt caching mechanism. On the left, our massive block of 20+ examples is processed once and stored in the Anthropic cache layer. On the bottom left, subsequent API requests come in with just the new user query. They bypass the heavy processing step, immediately hitting the cache, merging with the examples, and generating the output. You achieve high accuracy, many-shot prompting at a fraction of the computational cost. To wrap up, few-shot prompting is arguably your most reliable tool for steering Claude's output. Start simple with zero-shot, find where the AI struggles, and inject targeted examples to fix those specific failures. Remember the golden rules: use 2 to 3 examples, make them relevant and diverse, and structure them cleanly with XML tags to avoid confusion. Treat your prompts like software: iterate, test, and monitor. Thank you for joining this deep dive into AI engineering. If you found this training valuable, please like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Let's keep building amazing things together. Our final diagram shows the prompt engineering lifecycle. You start by drafting a prompt with zero-shot. You test it, identify failure points, and then inject targeted XML examples to create a robust few-shot prompt. You deploy, monitor, and continuously feed edge cases back into your examples. This iterative loop is the secret to mastering AI development. Thank you again. Head over to quicktechie.com and happy prompting.